To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the earlier chapter, I have introduced for you guys what are the things or what are the solutions that pass electricity and what are the solutions that do not pass electricity. Okay, and the solutions which can pass or conduct electricity was called as electrolytes, and the solutions which cannot conduct electricity are called as or was called as non-electrolytes. So those are the two main types of solutions that we can identify: electrolytes and non-electrolytes. Okay, so now we are going to study about examples for electrolytes. Okay, examples for electrolytes. So you know that electrolytes are the things or the substances that can pass or conduct electricity. Electrolytes are the things or the solutions that can pass or conduct electricity. So we are going to identify several examples for these electrolytes. Okay, examples for electrolytes. So you are given with the first one, number 1, solutions of ionic compounds. Solutions of ionic compounds. So let's see what is this ionic compound is. Okay, what kind of a thing is this ionic compound? Compounds such as sodium chloride. Sodium chloride. Okay, sodium chloride. You know that sodium chloride is also called as the common salt. For common salt, this is the chemical name, sodium chloride, right? Sodium chloride is the chemical name for common salt, sodium chloride. Okay, check the specialty here. I'm going to circle out the specialties. Okay, all right. Okay, I'll explain these things, then I'll write down the examples, then you should know or you will know what kind of a thing is this ionic compound. Then next one, copper sulfate. Copper sulfate. So compounds such as sodium chloride and copper sulfate are known as ionic compounds. They exist in the solid state. Copper sulfate is a blue color solid crystal. Copper sulfate, right? Sodium chloride or common salt is a white color solid crystal. You know that both of these solid substances or these crystals are readily dissolving in water. Okay. Let me explain you about these ionic compounds then. So I'm going to take the slide somewhat up to explain you about the ionic compounds. Now let's see what are ionic compounds. Copper sulfate. Copper sulfate. Sodium chloride. Sodium chloride. Calcium carbonate. Calcium carbonate. Magnesium chloride. Magnesium chloride. Sodium sulfate. Sodium sulfate. Then potassium hydroxide. When you check these chemicals, now these are several chemicals, my dear children. Copper sulfate, sodium chloride, calcium carbonate, magnesium chloride, sodium sulfate, potassium hydroxide. several chemicals. If you check these substances, which I am going to underline over here, copper, sodium, calcium, magnesium, again sodium and again potassium is there. So let's erase this thing. We'll use a different one over here. Sodium is already there now. Let's take a different one. I'll take a different one over here. Let's take, okay, silver sulfate. Silver sulfate, right? So all of these substances are, my dear children, all of these things are ionic compounds, right? All of these things are ionic compounds. So let me explain about the specialty in ionic compounds then. So I have underlined their specialty over here. What is the specialty? Ionic compounds, these ionic compounds, see, copper, sodium, calcium, magnesium, silver, potassium, all of these substances are, my dear children, all of these things are metals. All of these substances are metals. As you can see here, it's very clear to us that all of these substances like copper, sodium, calcium, magnesium, silver, potassium, all of these substances are metals. Ignore about this part. Don't think about this. I'm talking about these underlined ones. All of these things are metals. If a certain chemical contains a metallic item or metallic element within the compound, if a certain compound contains, right, a metallic element within it, metallic element like copper, sodium, calcium is a metal, okay? So magnesium, already you know that it is a metal. Silver, a good metal. Once again potassium, again a metal. All of these substances are metals. We divided metals and non-metals in the lesson part that we are, when we are studying about the lesson part, structure of the atom or structure of the matter, right? So we discussed about what are the metals and what are the non-metals. So you already know that these things are metals, my dear children. Ionic compound is a compound that contains a certain metallic element within the compound. Like when you take copper sulfate, copper is the metallic item present in it. Sodium, the metallic item. Calcium, once again a metallic item. Magnesium, same. Silver, potassium, also the same. If a certain compound contains a metallic item or metallic element, then my dear children, this compound is an ionic compound. It is an ionic compound. This is just a brief, okay? Up to your knowledge how to identify an ionic compound. Just a simple brief. You will learn about these ionic compounds in grade 10. Even more things that I'm going to tell you right now. Okay? Just for your knowledge, if a certain ionic compound has, or if a certain compound has a metallic element, then my dear children, it is an ionic compound. Sodium chloride, the name sodium is a metal. Copper sulfate, the name copper is a metal. So my dear children, sodium chloride and copper sulfate are ionic compounds. Ionic compounds. If a metal is there, then it is ionic. Simple. So all of these substances which I have written here contains a metal. So therefore these substances are, my dear children, ionic compounds. Ionic compounds. So these are ionic compounds then. Right? Compounds or substances that contains a metallic element within the compound. Let's come back down once again. So compounds such as sodium chloride, copper sulfate are known as ionic compounds. They exist in the solid state. We know that those substances exist in the solid state. They are made up of oppositely charged ions formed by the relevant atoms. You will be able to learn more about them in grade 10. So like I said, right, we'll be learning more about these things in grade 10. You will get to know about these things in detail within grade 10. Just for now, I'm just giving out a brief. Okay. So, specialty here is that they are made up of oppositely charged ions formed by the relevant atoms. Right. Very special. They are made up of oppositely charged atoms So they are made up with oppositely charged ions formed by their atoms. Very special. Once again, now you have come across with the term called ions here. So I promised you that I'm going to explain about these ions and about the mobile ions within this chapter. Okay. So let's head on to see what are these ions then. I'm once again coming to this one. If you write copper sulfate, the chemical name of copper sulfate or the chemical formula for copper sulfate is CuSO4, copper sulfate. Sodium chloride, NaCl. Calcium carbonate, CaCO3. Magnesium chloride, MgCl2. Silver sulfate, right? So let's see. Ignore about these things. Check these things, okay? Most common ones. Copper sulfate, sodium chloride, calcium and magnesium. Specialty here is that, my dear children, these substances are made by, okay? These substances are made by, right, oppositely charged ions. The previous sentence told that thing, right? So what do you mean by oppositely charged ions? It's like this. I told you that metals have weaker attractions between their electrons and the nucleus of the atom. Weaker attractions. So metals has the ability to remove electrons and to create positive charges. Once again, to remove electrons and to create positive charges. Okay? If you take an atom of copper atom has the ability to, one copper atom, a particular copper atom has the ability to remove the electrons present within the shells, right? To remove these electrons and to be positive. How come the atom is becoming a positive one when removing electrons? It's like this. Okay. Let's imagine that I'm a bad person. Okay. I'm a bad person. If I'm a bad person, I'm having several negative, somewhat bad, behaviors in simple. If I'm bad, then I'm having bad behaviors. That is why I'm bad, right? So if I want to be good, what should I do? There are two possible things. One thing is that I need to practice good behaviors, or else there is another method. I can eliminate my bad behaviors. If I'm going to eliminate my bad behaviors, automatically I'm getting good. Right? If a person is bad, then if he or she can eliminate the bad behaviors, automatically that person will definitely get good. Right? In the same way, let's imagine that, okay, or let's take that electrons are the bad charges. As they are negative, negative means bad. Let's imagine like that, negative, bad charges. Positive are good charges. So negative, you know that electrons are negatively charged. So electrons are bad charges. This is just for a expression, okay? Don't take it much serious. I'm just explaining you this thing like in simple methods, okay? So electrons are bad charges. So I told you that these bad charges have a weaker attraction between the atom, nucleus of the atom, and the external electrons. These bad charges have weak attractions. So this one has the ability to eliminate that bad charge. If a bad charge is getting eliminated, automatically this one becomes good. Right? Automatically this one is becoming a good one. Definitely it should become a good one. Because when you eliminate the bad, it becomes good. So that's what happens in here. Right? I told you that copper has the ability to remove that electrons which is located within the energy levels of them. Okay? These atoms can remove electrons or expel electrons as they have weaker charges. So the electrons present within copper is going to obtain by this sulfate group. This is a group, okay, sulfate group. So what will happen? This copper sulfate is made up with two different charges like this. When copper is going to remove or expel these bad charges or electrons, it becomes copper plus or positive. Copper is going to become positive. Okay. So these removed ones are obtained by, right? These removed ones are obtained by the leftover part, which is SO4 group. It becomes minus. It becomes minus. These are static electrical charges. Okay, these are static electrical charges. So copper becomes positive, this one becomes negative. As they have static electrical charges, they would attract together to create copper sulfate. That's how the copper sulfate is being created, by the joining of opposite charges, copper and the remaining one sulfate. So always the metal is the one who is becoming a positive one, and the remaining part is the one which is becoming a negative one. These kinds of charges bear by a certain element is referred as an ion. So this is a positive ion. Positive ion. If you can observe a certain charge within an element or group of elements like this, those things are referred as ions. So copper is an element. Copper plus is an ion. Actually, copper is not creating plus, right? Here within this one, copper is not creating positive. Actually, this is copper 2 plus 2. Means that it is going to remove two bad habits or two bad behaviors, which is similar to the removal of 2 electrons. And sulfate is becoming 2 minus. So like I said, you will be identifying these things in detail, how these charges are getting created in grade 10. Up to now, you remember like this. Up to now, simple terms. In ionic compounds or ionic compounds like these, you know that ionic compounds contain a metal. So these ionic compounds are made by positive metallic element with a negative other relevant group or element. Okay. So copper sulfate is made by positive copper and negative sulfate. Then sodium chloride, how it is made? Sodium chloride is made by positive sodium and negative chlorine. Like in the same way, calcium is made by calcium positive and carbonate negative. Magnesium once again made by magnesium positive and chlorine negative. Don't think about the numbers, just imagine that's just you imagine about their charges. Always remember, a metallic element is getting a plus charge as it can remove electrons or that bad habits. So when removing bad habits, it become positive or a good one, right? So a metal can create a positive charge while the other remaining one is creating a negative charge. So these positives and negatives are joined together to create that particular element or particular compound, right? Which is called as the ionic compound. So in an ionic compound, when you go through to the ionic compound, you can observe two different kinds of substances that has two different charges, positive and negative. Always the metallic element present in it gets a positive charge and the other group or the element is going to take a negative charge. So this is how these substances are getting created, ionic compounds. So you know that when joining these positives and negatives together like this, their bond is very strong. So as these bonds are very stronger, in the solid state, I mean like when they are creating their normal conditions, normal compounds, they can be identified in the solid state as the bonds are much powerful, large amount of bonds or large amounts of compounds, large amounts of these substances are tightly packed each other. Why they are tightly packed? Because they have much stronger charges, static electrical charges. So these things are tightly packed each other. So upon having that tight particles, these can be observed only in solid state, in our normal room temperature. In our normal environment, all the elements or all the compounds, all the ionic compounds are available as solids. Okay, solids. Now I told you, my dear children, in order to transfer electricity, there should be mobile electrons. Otherwise, they can't conduct electricity. Now, you get to know that these ions are, or these compounds are made by ions like these. So there are positive ions and there are negative ions like this, okay, within the ionic compounds. So each and every ionic compound is made by combination of a metal with a relevant non-metallic group, okay. And my dear children, the other specialty is that these ionic compounds are made by a positive metallic charge and a negative other kind of a charge. Okay, other kind of a charge means actually other kind of a compound or else an element. So that other one is getting negative. Always the metallic item is getting a positive charge. This is how the positives and the negatives are getting separated, right? This is how the positives and the negatives are getting separated within an ionic compound. All the ionic compounds are created like this, from positive charge and a negative charge. Always the metallic item is the one which is getting a positive charge. The other specialty is that as they are bonded with strong static electrical charges, elements and the other, I mean like the particles are tightly compacted each other. These particles are tightly packed each other. So therefore, all the ionic compounds are available in the environment as solids. Okay, these are available as solids. So within the solids, you won't be able to identify any electrons or any other thing that can conduct electricity. So the other specialty is that within the solid state, these ones will not be able to conduct electricity. But in the solid state, remember, in the solid state, they won't be able to conduct electricity. Okay, solid state, they don't conduct electricity. Right then. So let's head on to see what are the other contents in the. Although there are ions in solid ionic compounds, they cannot move freely. So like I said, copper sulfate in the solid state, these cannot move freely. Means that they are tightly packed. Like I said, these charges are tightly packed. So when creating a solid, these things are tightly packed. So solid, in the solid state, they won't be able to conduct or do any kind of a stuff, as they are not moving, right? They are tightly packed within the solid. Then hence those compounds do not conduct electricity in the solid state. So in the solid state, these compounds or these substances will not be able to conduct electricity. Solid state. But if an ionic compound is dissolved in water to give an aqueous solution, the ions in it become mobile. Thus, aqueous solutions of ionic compounds are good conductors of electricity. Now what happens? What happens here is that, let me erase this thing, my dear children. So I hope that you got an idea about the ionic compounds. So ionic compounds are the substances, right? Ionic compounds are the substances that carries a metal, like copper sulfate, sodium chloride, calcium carbonate, magnesium chloride, silver sulfate, potassium hydroxide. Okay, so I'm going to erase this thing now. So let me explain what are these mobile ions. Okay, let me explain about the mobile ions then. So you know about the ion. Ion is a charge carrying element, right? It is an element that has a charge. A charge carrying element is referred as an ion. So if it is a positive charge, then it is called as a positive ion. If it has a negative charge, then it is called as a negative ion. So let me erase this thing also, right? So I'm going to explain what happens after that. So when you take this thing, right, when you take the ionic compounds, how can we create these ions mobile? So let me explain how the mobile ions are getting created from a solution, like from these substances. So when you dissolve, let's imagine that I'm going to dissolve copper sulfate in water to make copper sulfate solution. So copper sulfate solution. When dissolving copper sulfate, what happens here is that, my dear children, in the solid state, they are not being separated into ions like that. They are made up with ions, positive and a negative ion. However, in the solid state, due to having these extreme, right, static electrical charges, they are bonded together, right, and these bonds are much stronger. And the case is that in the solid state, these bonds are not getting separated and these bonds are not, or these compounds are not creating these ions. These ions are now joined together to form the compound copper sulfate. But when you mix it with water, what happens? This is the solid. It is available as copper sulfate, right? It is available as copper sulfate, the solid, right? So copper sulfate, the solid copper sulfate available like this. The thing is that even though copper sulfate is available as a solid in the solid state, even though it is available as copper sulfate, within the liquid, my dear children, they are getting separated into plus and minus ions like this because of the solution, right? Because of mixing this substance with water, because of making an aqueous solution. What will happen here? Water will go through with the substance over here and it will separate plus and minus charges. So within the solution, now you can observe copper plus ion and this SO4 or the sulfate minus ion, particular minus ion. Now what will happen? when you connect an electric source into this. Now you know that from the negative terminal electrons are coming. So these electrons have the ability to repel these negative charges to the other side, or these negative charges has the ability to repel these electrons to the other side. Not only that, the positive copper charges has the ability to attract electrons towards its side, because you know that electrons are negatively charged and this is a positively charged item. So what will happen? Copper will attract electrons and it will allow two electrons come to that particular solution. So when electrons are coming towards that copper plus, my dear children, and to that side, when it is coming to that side, automatically once again it is being attracted by this positive terminal because of the lesser potential of electrons. So what will happen? Copper plus can attract electrons towards the positive side and electrons will come and move to that particular direction as a flow or as a beam. Okay. So these kinds of ions which are present within the solution are referred as mobile ions. In here, there are no any mobile ions. What is the reason? Because in the solid state, these charges are fixed together and not getting separated. However, when you mix water with these, water goes through that and it is getting separated. So, copper sulfate. So, when electrons are coming, sulfate can push those electrons towards that side. Copper can attract those electrons towards this side. So, automatically it will travel to the positive terminal, my dear children, and through the solution, a beam of electron will travel for sure. If a beam of electron is traveling through a solution or any kind of a substance, definitely electricity is passing. A beam of electrons is called as electricity. Beam of electrons which are moving to a certain direction is called electricity. So this is how mobile ions are getting created, and this is how solutions can conduct electricity. Okay, solutions can conduct electricity because of having mobile ions. In order to have mobile ions, my dear children, these kinds of substances, ionic compounds, should be there, but in a liquid state. It should be in a liquid state. Okay. In the liquid state, their ions are getting separated as positive and negative. These positive and negative ions can, right? These ions will able to deflect the upcoming electrons towards the positive side or towards the positive terminal. That is how the electricity is getting passed. Okay. So this is how, right, this is the way of conducting electricity through an electrolyte or a solution that can pass electricity. So within the solution, there should be positive ions and negative ions, my dear children. So copper sulfate in the solid state, it is becoming a solid like this with opposite charges tightly packed together. But however, when you dissolve it in water, what will happen? Charges are getting separated into plus metal and the related negative one, and these plus and minus charges can able to deflect electrons through the solution. So the solution will have the ability to conduct electricity. Okay. So these kinds of charges which present within a solution which are mobile, those things are mobile. I mean, like, those things are not showing any attractions, right? Those things are not showing any attractions between any kind of a particle. So therefore, they have the ability to move here and there within the solution. So these kinds of ions which are present within the solution are called as mobile ions, my dear children. Mobile ions. So if there are mobile ions within a solution, then the solution can conduct electricity. Okay, in order to create mobile ions, my dear children, the other specialty is that these kinds of substances should be mixed with the solution, right? These substances are referred as what? Ionic substances or ionic compounds. So in an ionic compound, you can observe a metal. Okay, you can observe a metal, right? So this is the secret behind the electrical conductivity in electrolytes, my dear children, right? So as you can see here, although there are ions in the solids, in solid ionic compounds, they cannot move freely. So in the solid item, they cannot move freely. Ions will not get separated. So those compounds do not conduct electricity in the solid state. So therefore, in the solid state, they won't conduct electricity. But if an ionic compound is dissolved in water to give an aqueous solution, now what do you mean by an aqueous solution, my dear children? Aqueous solution means when you mixed with water a certain substance, the solution which is getting made is referred as an aqueous solution. Aqua means water. Aqueous solution means, right, when you mix the certain substance with aqua or water, the solution or the resulted liquid is the one which is referred as an aqueous solution. So when you mix salt with common salt with normal water, aqueous solution of sodium chloride or common salt can be formed. When you mix copper sulfate with water, aqueous solution of copper sulfate can be formed. Okay, it could be formed. So this is how we can create aqueous solutions. You just take water and dissolve the particular compound, ionic compound within it to create an aqueous solution. So aqueous solutions of ionic compounds, they have mobile ions. Ions are getting separated. So these ions have the ability to transfer or to repel electrons which are coming from an electric source. So therefore, these ionic compounds, solutions of these ionic compounds, especially aqueous solutions, they have the ability to conduct electricity. So the first example for the electrolytes, my dear children, the first example for the electrolytes, examples for electrolytes, under that the first one, solutions of ionic compounds. Especially we discussed about the aqueous solutions here. Ionic compounds are the compounds that has a metal. When you dissolve this ionic compound in water, ions are getting separated. Always the metallic item is the one which is getting a positive charge, and non-metal or the relevant other group is getting a negative charge. That's it. Okay. Right. Now, let's head on to see whether there are any other forms of solutions in ionic compounds. Actually, there is. See, when an ionic solid is heated, okay, when an ionic solid is heated and brought to the liquid state, now what will happen? Now what is going to happen here? We are going to heat a certain ionic compound, heat like up to 800-900 degrees of Celsius. Let's imagine common salt. I'm going to take a piece of common salt and I'm going to heat it up to 900, like 1000 degrees of Celsius. Now what will happen? Now, my dear children, definitely it will get melt, right? It will get melt. And this melted sodium chloride is also a type of a solution, right? There is also a solution, no? So here, when an ionic solid is heated and brought to the liquid state, it is called as a fused substance. So this is called as a fused substance. Fused, or this is also referred as a molten substance. Molten or fused. Fused or molten substance, right? Fused substance. Ions in a fused liquid also can move. Now what we do here? If you can heat a certain ionic compound up to its melting point, automatically these things will get melt, and within that solution, my dear children, in the solution, ions are getting separated. Here you provide heat energy to separate ions in it. Okay. When providing heat energy, that extreme bond is going to break down at a certain instance and getting separated into ions. In that case, you know that if they are tightly packed like this, then it is a solid. If the charges are getting, if the compounds are getting separated and if particles are like this much of a gap, then it is going to be a liquid. Because you know that particles are tightly packed in a solid. However, particles are not that much tightly packed in a liquid. So, we provide heat energy to break down these strong attracted bonds so that they would convert like this with a certain space. So, upon creating a space between particles, definitely they will turn into what? They will turn into the liquid state. Okay. Definitely they will turn into liquid state. So this is how, right? This is how, my dear children, the ions are getting separated within a fused solution of ionic compounds. Fused means we are providing heat energy and converting this solid into a liquid by providing heat energy till the melting point. Okay, right. So here, when an ionic solid is heated and brought to the liquid state, it is called a fused substance. Ions in a fused liquid also can move. Now, accordingly, ionic compounds conduct electricity in the fused state. So, in the fused state and also in the aqueous state, right? No matter if an ionic compound is a solution, then definitely it's going to conduct electricity. Definitely it's going to conduct electricity. If an ionic compound is in liquid state or else in solid state, definitely it's going to conduct electricity. No matter the state. If it is a liquid, then it is going to conduct electricity. It's because that their ions are getting separated and these ions have the ability to repel or attract electrons to a certain direction. By that way, a beam of electron is going to pass through the liquid, means it conduct electricity. So, examples for ionic compounds. You are given with examples for ionic compounds topic. However, 3 things are given. Examples are not written. So, we will write down several examples, my dear children. Sodium chloride. Sodium chloride. Here, it is written as NaCl. NaCl. The chemical formula is NaCl. Sodium, we refer that thing as natrium. So, natrium is given by the symbol Na. Chlorine, Cl, right? Chloride. So, here, ions are getting separated as Na plus and Cl minus. Okay? Na plus and Cl minus. But only within a solution, not in the solid state, remember. Then copper sulfate. Copper sulfate. CuSO4. Here also ions are getting separated as copper plus and SO4 minus. So, like I said, my dear children, you will be learning about these things in detail in grade 10. So, when you are going to grade 10 or when you are learning these things in grade 10, you might understand that actually copper is not creating copper plus at this time. Here it is copper 2 plus and the sulfate is SO4 2 minus. Not just minus, 2 minus. Okay. Up to now, you just don't think about that thing. Up to now, you just remember, okay, you just remember that the metal is creating a certain positive charge while the other part is creating a negative charge. This is how the ions are getting separated. Then, another example is magnesium chloride. Magnesium chloride. Magnesium chloride, MgCl2. Once again, here 2 chlorines are getting minus and magnesium is getting plus. This is how the ions are getting separated in a solution, only in a solution. Remember that, not in the solid state. Ionic compounds are present in solid state in our normal environmental conditions. You have to make solutions in order to separate their ions. So these ions contained in solutions are electrolytes, or they can conduct electricity. Remember that thing, my dear children. In the normal environmental conditions, these compounds cannot conduct electricity as they are in the solid state, and there are no any mobile ions in the solid state as they are tightly packed within the compound. However, when you are making solutions like this way, the ions are getting separated. These ions have the ability to transfer electricity or transfer that electrons from one place to another. Okay, right. So this is the first and foremost example for the electrolyte. So the first example is solutions of ionic compounds. So solutions can be even in fused state or else in liquid aqueous state. Now let's head on to see the second example. Aqueous solutions of acids. Now when you dissolve a certain acid, right, in water to make an aqueous solution of acid, aqueous solutions of acids are also creating mobile ions. Okay, special thing. Aqueous solutions of acids are also creating mobile ions. So here it is given, when an acid is dissolved in water to give an aqueous solution, ions are separated and become mobile. Thus, aqueous solutions of an acid are good conductors of electricity, right? So aqueous solutions of an acid are good conductors of electricity. So I think you could remember about the acidulated water or acidified water. We took a sample of water and we put some drops of acid. So it became a conductor. It's because we have mixed the acid. Okay, we have mixed the acid. So when you mix acid with water, right, what will happen? It will have mobile ions, like in the previous case. So these mobile ions will have the ability to conduct electricity, right? So therefore, aqueous solutions, my dear children, aqueous solutions of acids, they have the ability to conduct electricity, right? Aqueous solutions of acids, they have the ability to conduct electricity, right? So examples for acids. What are the examples for acid? Normally, we use several acids in our laboratory. In grade 10, we'll be studying about 3 main acids. Okay, so I'll write down those 3 main acids and another example for an acid that we used in our day-to-day life. So acids, my dear children, the first and foremost acid that we used, that we can use or that we are going to use in our laboratory is that hydrochloric acid. A very strong acid, hydrochloric acid. The chemical formula is HCl. Here, when these things are, or when acids are getting dissolved within water, right, when acids are getting dissolved within water, ions are getting separated as hydrogen plus. Hydrogen is the one which is getting separated as plus, and the relevant other one is getting into minus. Okay, so this is how ions are getting separated within an acid. However, you have to mix this acid with water to make an aqueous solution. So when making aqueous solutions of acids, hydrogen is getting separated into positive and the other relevant part is getting into negative. Okay, then sulfuric acid. Sulfuric acid. H2SO4. H2SO4. Here also hydrogen plus and SO4 is becoming minus. Okay. Next one, nitric acid. Nitric acid. HNO3. Hydrogen plus, NO3 minus. Okay. Then a day-to-day acid that we use, acetic acid. Acetic acid is commonly referred as vinegar. Vinegar. Chemical name is given as CH3COOH. So I'm not going to write down how the mobile ions are getting separated. Actually, it is getting separated as CH3COO minus and hydrogen plus. Okay, you don't think about that thing. Okay, so actually now within this lesson you have learned several extra things. Okay, right, when you are studying about the lesson part, you have studied several extra things now, and I think that you got a good idea about the lesson part about the electrolytes and the non-electrolytes. Well, right, so these are the examples for acids, my dear children. So in each and every acid, what will happen? The hydrogen part is getting separated into plus, and the related one, the other one, is getting separated to minus. So these plus and minus are conducting electricity within the aqueous solution of the acid. Okay, so hydrochloric acid, sulfuric acid, nitric acid are the three main types of acids that we learn in our laboratory, that we are going to learn in our laboratory. These are the three main types of acids. However, mostly we are using these two acids, my dear children, hydrochloric acid and sulfuric acid. This sulfuric acid is also called as battery acid. Battery acid, right? Battery acid. So it is referred as battery acid because for batteries, lead acid accumulators, we add sulfuric acid. Okay, battery acid. Right. So examples. This is the second example for electrolytes. First example was solutions of ionic compounds. It can be fused or aqueous. Then the second example is aqueous solutions of acids. Okay, acids like these. Right then. So let's head on to see third type, my dear children. Aqueous solutions of bases. Aqueous solutions of bases. Okay. So like in acids, aqueous solutions of bases are also conducting electricity. In here also, what will happen? These solutions will have the ability to conduct electricity because ions are getting separated within the solution when the base is when a base is dissolved within water, right? So when a base is dissolved within water to create a solution, an aqueous solution, what will happen? Automatically, my dear children, ions will get separated within the solution, and these ions will have the ability to conduct electricity, which I have explained earlier, like in the way which I have explained earlier. Okay. So bases, aqueous solutions of bases are also good conductors of electricity. Therefore, these are also examples for electrolytes. So here you are given, like an acid, a base is dissolved in water to give an aqueous solution. Ions are separated and become mobile. Therefore, aqueous solutions of bases are good conductors of electricity, right? So when a base is dissolved in water to get an aqueous solution, that aqueous solution will have mobile ions, and these mobile ions will conduct electricity. So therefore, aqueous solutions of bases are considered as good conductors of electricity or electrolytes. So examples for bases: So there are several examples for bases, my dear children. We'll write down 3 of those. Potassium hydroxide. Potassium hydroxide. Chemical formula is KOH. K is for kalium. You know that potassium is referred as the name, special name, kalium, right? Kalium. So kalium, that is why potassium is given as the letter K. So kalium in here, potassium hydroxide, K is positive. You know that if there is a metal, then the metal is getting separated into a positive ion. Always a metal is getting separated into a positive ion. Potassium hydroxide is also an example for an ionic compound. Actually, these examples for bases, within the examples for bases, my dear children, we can identify ionic compounds. Okay. These metals like potassium are referred as alkali metals, as they would create bases when dissolving in water. Okay. So these metallic substance can be identified within the bases, my dear children, right? So therefore automatically it becomes an ionic compound. You know that the ionic compound is going to conduct electricity. Okay. So another example is sodium hydroxide. Sodium hydroxide, NaOH. So Na is becoming plus, OH is minus. When you dissolve sodium hydroxide in water, sodium is separated as sodium plus and OH part is separated as OH minus to create mobile ions within the solution. Next one, another one, calcium hydroxide, which is also referred as the lime water, right? Calcium hydroxide. So calcium hydroxide, Ca, Ca within bracket OH twice. So here it is getting separated as calcium plus and OH minus. You don't think about the charges like this, my dear children. Actually it is here, calcium is 2 plus. So don't think about that thing. Just I have written how the positive and the negative is getting separated over here. I didn't consider about the value of the charge. So these values you will learn in grade 10. Okay. So don't think about their values. You just remember metal is getting separated always as plus and the other one is minus. So in a base it's very simple. In a base, my dear children, actually bases are good examples for ionic compounds as they contains metals like potassium, sodium and calcium. So you know that these substances are getting separated within a solution like this to create mobile ions. So if they have mobile ions, definitely they are electrolytes. Okay, means that they can conduct electricity. So this is the third example for electrolyte, my dear children, aqueous solutions of bases. Aqueous solutions of bases. Okay, right then. So we have identified 3 examples related to electrolytes. Okay, solutions of ionic compounds. Ionic compound is a compound that contains a metallic substance like copper sulfate, sodium chloride, right? Then silver chloride and so on. If it contains a metal, then it is an ionic compound. Usually ionic compounds are available as solids because as they have charges like plus and minus, these charges are strongly bonded in nature, creating a solid. However, when these solids are forced to make a solution, it can be an aqueous solution. When the solid is mixed with water, the aqueous solution is getting formed. Or else it can be a fused solution. Here we are going to heat the substance till the melting point to make into a solution. No matter the type of the solution, these things, within these things or within these solutions, my dear children, plus and minus charges are getting separated. So these plus and minus charges are referred as mobile ions, as they have ability to reflect and move here and there within the solution. So when an electric source is providing electricity, in simple a beam of electrons, these mobile ions have the ability to reflect or else to attract electrons. So by that way, the solution is going to conduct electricity. So the first example, aqueous solutions of ionic compounds and fused or molten solutions of ionic compounds. In common, we can say that solutions of ionic compounds, good conductors of electricity, means good example for an electrolyte. Second example, aqueous solutions of acids. Aqueous solutions of acids also creating plus and minus charges when they are mixed with water. So these things are going to conduct electricity. So therefore, aqueous solutions of acids are good examples for electrolytes. Then the third one over here, aqueous solutions of bases. Usually base contains a metal like potassium, sodium, calcium. So you know that these metals are getting separated like these, positive, and the relevant other one as negative. So these positive and negative charges or these positive negative ions will have the ability to move within the solution to conduct electricity. So aqueous solutions of bases are good examples for electrolytes. Then we are moving on to the last and the final type, which is the acidulated water, right? Acidulated water, my dear children. So in acidulated water, what you have to do? See, pure water is not a conductor of electricity and it is a non-electrolyte. Pure water, you know that water is made by hydrogen and oxygen. Water is made by hydrogen and oxygen as H2O. In here, there are no metals. Hydrogen is a non-metal, oxygen is also a non-metal. So pure water do not have the ability to separate into ions. Okay. So therefore it is an non-electrolyte. See, pure water is also referred as distilled water, my dear children. Distilled water. So like I said, distilled water or pure water do not have the ability to conduct electricity. So it is an non-electrolyte. When we are doing that experiment in the previous chapter, I think you could remember we used a sample of distilled water to check the ability of electrical conductivity. Over there, we could clearly observe that the distilled water will not deflect the ammeter reading, right? It will not deflect the ammeter reading, right? It did not reflect at the ammeter reading. It's because that distilled water is not a conductor of electricity. There are no mobile ions within the distilled water. But what will happen if you pour several drops of an acid to distilled water? See? So here it is given, pure water is not a conductor of electricity, non-electrolyte. Here mobile ions are not created. But when few drops of an acid are added, few drops of acid is going to be added. We are going to add several drops of acid. So here, when few drops of an acid are added, ions are separated in water and become mobile. Now what will happen? When certain things are getting dissolved within water, my dear children, when certain substances are getting dissolved within the water, water has the ability to separate into ions. But however, not in pure water or distilled water. In distilled water, like I said, I told you, there are no any substance. So substances are not there in pure water. Only water molecules can be observed. However, if you can dissolve several substances like an acid or else a base or any kind of other substance which is readily dissolving in water, it should readily dissolve in water, okay? Then these solutions, right? These solutions have the ability, some of these solutions have the ability to conduct electricity. It's because ions are getting separated in water. That's the reason. So here, my dear children, water is getting separated into H plus and OH minus ions. Not as hydrogen plus and O minus, but hydrogen plus and the other relevant group is OH minus. So you'll be learning about these things in detail when you go for the further grades. Up to now, you just remember when you mixed several drops of acid with water, the water molecule is getting separated into hydrogen plus and OH minus. Okay? When you dissolve an acid, or when you dissolve, or when you drop few drops of acid, okay, when you put few drops of acid to a water container, right, water molecules is getting separated into hydrogen plus and hydroxide or OH minus, right? So these ions are getting mobile. So these mobile ions can conduct electricity. So here it is given, water added with few drops of acid is called acidulated water or acidified water. This acidified water will have the ability to have or to create mobile ions within the solution. So therefore, acidulated water is a good example for electrolytes. Okay, it is a good example for electrolyte, acidulated water. Okay, remember, when you put few drops of acid to water, ions are getting separated. Okay, ions are getting separated. If you take rainwater, my dear children, rainwater is somewhat acidic, like the acidified water. That's why the rainwater is going to conduct electricity, right? That's why the rainwater is going to conduct electricity. Okay, so I think you could remember when we are taking tap water, I told you those things are not pure water, and that particular tap water is also going to conduct electricity. When you add chlorine into it, chlorine is getting into chlorine minus, creating negative ions. If they have ions, then they can conduct electricity. Okay, so almost all the water that available in our normal environmental conditions, they have mobile ions. So that is why the water that is available in our normal environment is going to conduct electricity. Okay, so therefore, my dear children, remember, if there are mobile ions present within a solution, that solution is going to be an electrolyte, right? So distilled water, however, is not an electrolyte, but we can make into an electrolyte by adding few drops of acid. So that water is the one which is referred as acidulated water. And in acidulated water, ions are getting separated and it will conduct electricity, and therefore acidulated water is a good example for an electrolyte. So these are the examples for electrolyte, my dear children. So there are 4 types of electrolytes. What are those? Aqueous solutions of acids, aqueous solutions of bases, acidulated water, and solutions of ionic compounds. Okay, electrolytes. Right then. So now we have discussed about the electrolytes. Then you are given with a topic, examples for non-electrolytes. Examples for non-electrolytes. So here it is given. As we discussed earlier, non-electrolytes do not have mobile ions. So within non-electrolytes, my dear children, they do not have mobile ions. Okay. Usually these substances are made with only non-metals, covalent compounds. The reverse of the ionic compound, covalent compounds. Covalent compounds, you will be identifying about these covalent compounds when you go to grade 10. Up to now, I have just given you the explanation for these covalent compounds. Okay. So covalent compounds are the compounds that contain only non-metals. So if they contain non-metals, right, but there is an exception, right, there are several exceptions as well, like water, okay. So like I said, these things will be learned in detail in grade 10, okay. So up to now you just remember, if there are no special kind of metals, right, then my dear children, they don't have the ability to conduct electricity, because when these things are available as solutions, there are no any mobile ions in it, okay. So examples for non-electrolytes, you are not given with examples, so we'll write down several. Number 1, glucose solution, glucose solution, sugar solution. Sugar and glucose, they do not contain any, right, these substances do not contain any metallic items, okay, or metallic elements. So plus minus charges are not getting separated in glucose or in sugar. So therefore these are good examples for non-electrolytes. Sugar solution, right, glucose solution, sugar solution. Then number 3, kerosene oil, kerosene and coconut oil, right, both of these things are correct. And petrol, diesel, those are also correct, my dear children. Petrol, right, so that's enough, right. So these are the examples for non-electrolytes. So these solutions or these liquids, they do not contain, right, mobile ions. So therefore these things or these solutions will not be able to conduct electricity, my dear children, okay. So examples are glucose solution, sugar solution, kerosene or coconut oil, and petrol. So these are the examples for non-electrolytes, okay. So remember, non-electrolytes, they do not have mobile ions, okay. Mostly they are made up with substances only with non-metals, right. Mostly they are made up with only non-metals, but there can be exceptions as well, okay. But however, mostly they contain non-metals. So you know that in glucose there is carbon, hydrogen and oxygen. Sugar, once again carbon, hydrogen and oxygen. We discussed this thing, right. Then in kerosene, kerosene is a good fuel. Petrol is also a good fuel. Since grade 8 we are discussing that in a fuel, mostly carbon and hydrogen are present. And coconut oil also can be used as a fuel, right. You know that coconut oil can also be used as a fuel. So therefore coconut oil also contains, my dear children, carbon, hydrogen mainly, okay. So these substances, all of these substances are considered as non-electrolytes because these things do not contain any mobile ion within the solution. So I hope that you got a good knowledge about the non-electrolytes and the electrolytes, my dear children, okay, right. So I have explained the term, like I said in the previous chapter, I have explained the term called mobile ions, and I hope that you got the idea about the mobile ions thoroughly, right. So within our next chapter, my dear children, we'll be focusing about the process of electrolysis and how does the electrolysis is going to happen, right. And we'll be discussing that thing by doing several experiments related to several solutions, right. So in the next chapter, my dear children, we'll discuss further things related to the lesson.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.